On July 1, 2025, an object from beyond our star system announced itself. Moving faster than 130,000 miles per hour, it cut a bright, fast arc against the sky and immediately set astronomers talking. Catalogued by survey teams as 3 Atlas, it's only the third interstellar visitor we've ever observed, but unlike its predecessors, it behaves in ways that resist easy explanation. To put this in context, the 2 earlier interstellar arrivals taught us to expect the unexpected. The first was an elongated, enigmatic visitor that zipped through our system with no obvious coma and strange accelerations. The second looked and behaved more like a traditional icy comet, with a diffuse atmosphere and familiar jets as it warmed. Both forced astronomers to expand their view of what objects from other systems can look like. Yet 3 Atlas didn't fit comfortably into either category. From the moment it was tracked, something about its plume puzzled observers. A comet's tail typically streams away from the sun, pushed by radiation and the solar wind. But 3 Atlas displayed a narrow, persistent plume that pointed toward the sun, and it stayed that way for weeks. Multiple observatories, professional and amateur, recorded the same directional oddity. It wasn't an optical trick or a single instrument's artifact. The feature remained remarkably tight and steady even as the object swept through different parts of the inner solar system. Spectroscopy deepened the mystery. Instruments sensitive to faint chemical fingerprints reported unusually high levels of carbon dioxide, far more carbon dioxide than water vapor, the reverse of what is common in comets we studied. Even more surprising was the metal signature. Nickel appeared in the emissions while iron, ordinarily present alongside nickel, was conspicuously scarce. Taken together, the plume's geometry, the chemical mix, and the odd metal pattern presented a set of clues that didn't line up with the usual natural scenarios. Scientists initially tried to explain everything with conventional physics. Could buried pockets of frozen carbon dioxide be erupting in focused jets? Could an unusual rotation keep emissions pointed sunward? Could dust grains be unusually massive and resist being swept back by the solar wind? Each of those options was modeled and examined, but they strained to match observations, especially the plume's long-lived directional stability and the isolated nickel signal. When the numbers were plugged into simple thrust models, the behavior could also be reproduced by a small, continuous force applied in a fixed direction, the kind of gentle, sustained push one sees from engineered propulsion systems such as electric or ion drives. That possibility is not a claim of extraterrestrial intelligence, it's a hypothesis that must be tested like any other. But because the measured motion could be explained by a low but steady thrust, a fraction of the community has begun to entertain the notion of an artificial origin. Not necessarily a spaceship with visible features, but potentially a probe or engineered artifact designed to enter, slow, and observe. Some respected voices in physics have pointed out the plausibility of such maneuvers. Firing the low-thrust engine during the close approach to a star magnifies the effect, making precise slowdowns or course changes much more efficient. There are historical reasons why we worry. Earth's past includes a humbling example of a skyborne catastrophe. A massive impact event tens of millions of years ago reshaped the planet and led to mass extinctions. Modern sky surveys and planetary defense programs have vastly improved detection of many near-Earth hazards, but interstellar objects pose unique challenges. They arrive on trajectories and at speeds unlike most solar system bodies, and they can be hard to spot until they're already near. 3 Atlas was discovered after it had already entered, reminding us that our surveillance window can sometimes be narrow. The path of 3 Atlas is one of its most intriguing features. Most interstellar objects we've tracked cut sharply across the solar system, diving in at steep angles before vanishing back into deep space. They are brief visitors, like stones skipping across a pond. But 3 Atlas is different. Instead of a steep dive, it seems to be threading itself carefully through the solar system's main plane, the same thin cosmic disk where the planets travel. That's why it brushed past Mars, swung by Venus, and is now heading toward a close approach with Jupiter. This isn't just coincidence. Statistically, the chance of such a sequence happening by random chance is tiny. It looks less like a chaotic pass and more like a tour, as if the object is deliberately sampling planetary neighborhoods along the way. For many scientists, that detail alone is enough to raise questions. The intrigue deepened during the critical moment in late 2025, when 3 Atlas slipped behind the Sun from Earth's perspective. Astronomers call this a solar conjunction, a period when our line of sight is completely blocked. For spacecraft, it's a blackout zone. For an object with potential control over its own movement, it's the perfect cover to maneuver unseen. During those 2 weeks, no telescope on Earth or in orbit could track it. When it emerged in early November, astronomers raced to measure everything: its speed, its direction, the angle of its plume. On the surface, it seemed to reappear roughly where predictions said it would. Its path looked consistent. But scientists warned against rushing to conclusions. With an object moving at interstellar speeds, even the tiniest deviations, a fraction of a degree, a whisper of acceleration, a faint flicker of brightness, could mean everything. Did it slow down? Did it change orientation? Is the plume still locked sunward, or did it shift during the blackout? The answers to these questions are being teased out now, as astronomers pore over before and after datasets. The deeper meaning, though, is already clear. At the very least, 3 Atlas has expanded the playbook of what interstellar objects can be. Its behavior, whether natural or artificial, stretches the limits of our models. If it's natural, then it represents a kind of chemistry and physics we haven't catalogued before, a window into how materials form and behave in alien star systems. If it's artificial, the implications are staggering. It would mean that across the void, someone or something built it, guided it, and perhaps even pointed it toward us. Either way, the discovery is a wake-up call. Our current early warning systems are tuned mostly for asteroids and comets that orbit the Sun. They are not optimized for hyperfast interstellar travelers that burst into view with little warning. 3 Atlas showed us how easily such a body can slip into our cosmic backyard before we even notice. If the next one is larger, or on a collision course, we might not have time to react. That's why researchers are now calling for broader monitoring networks, more powerful sky surveys, and global collaboration to spot these interstellar visitors earlier. Meanwhile, telescopes around the world are watching relentlessly. Every flash of light, every spectral signature, every tiny change in trajectory is being recorded and shared. Computer models are being run and rerun, testing scenarios ranging from natural outgassing to controlled propulsion. Planetary defense teams are quietly reviewing what would happen if the next interstellar object weren't just passing by. And in all of this, 3 Atlas has already achieved something monumental. It has reminded us of our vulnerability, but also of our curiosity. It has forced us to confront questions that sound like science fiction but are now firmly within the realm of science. Could this be just an exotic comet? Or is it something built, something with a mission? If so, what is that mission, observation, exploration, or something we cannot yet imagine? In the end, 3 Atlas is more than an object. It is a mirror, reflecting back our own fears, our hunger for discovery, and our need to take the sky seriously. The universe is not static. It is alive with motion, with wanderers, with surprises that arrive without invitation. So we watch, we measure, we question. Whether 3 Atlas turns out to be a natural anomaly or a constructed machine, it has already reshaped how we think about interstellar visitors. It has whispered to us across the darkness, and now humanity must decide how to listen. Stay alert. Stay curious. Because the story of 3 Atlas is not over, and the next chapter may change everything.